Good morning, everyone. Hello, I'm Vidya, and I'm going to give a very brief overview or a graphics area introduction, or at least the way I see it. We can all agree that this is computer graphics. This is a short open Blender movie called Spring that released this year. And this frame sort of encompasses everything that graphics researchers work on. Appearance modeling, geometry processing, coming up with the meshes, simulation for hair, clothes, animation. And this entire movie was almost made with Blender, which is an interactive design system for making these things and programmable pipelines. And I'm going to look at fabrication through this lens of what graphics researchers traditionally work on. Texture mapping is a fairly common technique in graphics, introduced in the early 70s, used as a way to throw pictures onto meshes to make them look more realistic. And with 3D printing, we again see something like this, where texture mapping is being done in the real world, here with computational hydrographic printing. There's been a lot of work on generating color through color printers and things like that. There's also this really something that I wanted to point out, that there's also work within the graphics community from people who work on diffraction and things like that for generating color, but not from pigments, from printed geometry. So the colors that you see on the screen over here are generated from nanoscale structures that generate color. Much of graphics traditionally has been about generating geometry, creating geometry. Here's a really old video from the 1970s where this, I believe, is Ed Catmull's hand that he made a plaster form of, made polygons on them in order to create geometry. And this was manually scanned into a system. And this is still a very legitimate way of making 3D models if you want. But we've got a lot of 3D models now, and we're looking at fabricating models that probably aren't necessarily fabricable. And here's some work on making 2D fabrication possible by pushing out the curvature from surfaces. Within 3D fabrication and additive manufacturing, there's been a lot of interesting work with metamaterials. And here, what you see is a procedural generation of a foam-like metamaterial structure. In fact, this was done by our next keynote speaker. And the cool thing here is that none of these textures are coming from a library of textures or something like that. It's like procedurally generated. Again, there's a lot of work in graphics on, on simulation. If you've ever been on YouTube and click and enter graphics, you'll see a ton of videos like this, a lot of simulation videos. And a lot of this ends up being useful for fabrication as well. This is some early work that I really like on generating computational generation of rubber balloons. And the nice thing over here is that instead of changing the fabrication technique for making these structures, the input model is optimized in a way that when it blows up, it turns into this balloon structure. And without this sort of design optimization, you'd get something weird as on the left. Simulation is also getting more and more both accurate and efficient, which means that we can really come up with predictive simulation systems. And this is always useful for controlling in fabrication. And if you give a 3D printer to people who've thought of animation and locomotion, they're probably going to make things that move. Of course, in fabrication, the important thing is also that these need to work. So some animation cycles being 3D printed here. And there's been a lot of work on generating interactive design tools. Here's recent work on making a design system for sketching folds and garments and simulating them. The cool thing here, again, is that these have been made with feasibility and fabricability in mind, which means that the patterns change after you generate these folds and can be fabricated. in graphics, researchers have had a lot of success by in viewing things as a programmable pipeline for rendering and rasterization. And with OpenFab, researchers looked at promoting the same analogy for 3D fabrication, where you have these little phablets or texture programs that, with a multi-material printer, can be a nice way of generating different materials on your 3D printed structure, similar to how you would generally use a pixel shader, if you will. And since I have the stage, may I also plug my own work and work we've been doing here, where we've been also in a sort of similar way in viewing fabrication of knit structures. Here, a 3D model has been turned into a knit bunny, again with some amount of programmability with small programs to generate these structures. I hope that this sort of sampling of a small amount of work between graphics and fabrication sort of brings this idea of what ends up being useful in graphics and the kind of problems that people look at in graphics kind of naturally ends up being useful in fabrication as well. And with that short introduction, I'd like to introduce our next keynote speaker, Sylvain, who will be talking to us about texture generation and its uses for functional fabrication. Thank you, Sylvain.